All right, welcome back. We are on Unreal Workshop today, and the winter 2026 time frame at Georgian. And let's just go back down to where we left off. We talked about building some simple blueprints to make things rotate, and let's do that inside of our editor. So this is the challenge right now. Our cube kind of rotates, but weird because it rotates around its corner, and that's just the way it is, right? You can see that it's kind of rotating in a weird way, but that's okay. And it rotates every 5 seconds. And my challenge to you was make it rotate and bounce, right? So let's do this together. So the way to do this would be to add another timeline. And that's what I said to you guys before. I'm just recording this so you can see it again. So if I say add timeline, here it is at the end. I'm going to make this timeline cube bounce. We'll call it that. We'll connect it. So remember, we have to have execution flow all the way through from the event begin play all the way through to every node. Otherwise, if they're not connected, bad things will happen. If you were to try and do things from here to there, then it would disconnect the original ones. So you can see these ones now are disconnected, right? So we don't want that. We want to make sure it goes from one node to the other node to the third node. Okay, that's kind of a typical way of doing things. This doesn't really do anything. Cube bounce, let's add in a couple of keys. So double click in there. I'm going to add a new track, float track, just like we did before. I'm going to add in 3 keys, one at 0, and I'm going to use the value of, let's say, 50 or 40, doesn't matter. And then the next float track or next key is going to be at 2.5 seconds, and let's say 120. You can also use 100. And then I'm going to add another one, and that third one is going to be at 5 and back to 50. All right, so that's those are the 3 keys I added. I want it to loop, and I want to be able to see all my nodes, and so it kind of looks like this, right? Where you can see that I go from 0 or 50 to 120 and back down to 50, and it's going to loop over and over again. This track should be called, right-click, rename. It should be called location Z, because I only want to affect the Z value. That's up and down. X and Y values go across and forward and back. We don't want that. So now that I have this new timeline, what I want to do is I want to set actor location. So again, I want to set actor location, and you're going to say, wait, but it's going to disappear. And I'm going to tell you why it's going to disappear. Can anyone tell me why your stuff would disappear now? Yes? 0, 0 in the level. You see? 0, 0 in the level, that's not where we were before. This is one of the learnings I was trying to show you, which is, well, let's see where this cube is right now. This cube right now is at 960 and 570. Right? If I put this at 0, 0, let's put it at 0, 0. Oops, 0, 0. Right? You can't see it anymore because it's gone. But if I double click onto it, it's way over here. Right? So that's where it was. So 0, 0 is where it went, and that's not where we want it to go. We want it to stay where it was because it's actually in the wall. Look at it. It's like in the wall, right? So it probably will do what we tell it to do, but it will be not cool, right? You won't see it. So how do we do that? So we want to get the actor's location first. Let's try this next. That's one thing I didn't tell you. Let's do that. So I'll say get actor location. There we go. Get actor location gives you a node that's incorrect. It's a vector. We want these things. So we have to split the struct pin again. Let's do that. And so you can do something that looks like this, where I can take the current X and the current Y values, put them in here, and not use the Z value. We don't care about that Z value. That Z value is going to be controlled. Now, if you want to make your pins look nicer and your wires are pretty ugly, if you double click on a wire, it'll create a reroute node like this. Double click. And you can make this reroute node so that your wires can look nicer. Okay? Otherwise, your wires are going to cross underneath the other nodes, and they're really ugly. Right? So if you double click anywhere on a wire, it'll create a reroute node. Okay? And this is the proper thing that we want right here. So the event graph, just going to bring these a little closer so you can see them all in one screen. But this is what you should have.
Now, why not the actor local offset?
That's also another way of doing it.
Is it?
Yeah. There's more than one ways of doing everything, right? Yeah, so definitely, if you tried that out and it worked for you, awesome. Yeah, it's too much. It's probably too much. You're offsetting it too much, right? Because local offset means it'll add on to where it was, right? Okay. So now let's try this out and see what happens. So if I compile and save, and let's see if those values are good. Well, where'd it go? How come it's like, out of the world? And you're going to say like, wait, it's missing, it's gone, right? Because I get the actor location on update, I set the actor Z location up and down, and it's going to keep doing that over and over again. Well, what happened to it? We can follow the cube, my friends. So if you press play here, it doesn't really show you where the cube is, but if you go back to your game, oh, yeah, it's over here now. Sorry, I moved it. Because I moved it away. I moved it in the wall. Let's put it back somewhere where we can see it, over here. All right, let's try that again. So if I press play, now you're going to see it go up and down and rotate at the same time. It's going to do some weird rotation like this. Okay? So this is what you should have at the end. Let's take a look. I'll show you mine. I'll show you mine. Here. You gave up? No. Don't give up. Just when you started to explain it, I know. It's just my report. Exactly. Not bad. The rest is just a play. I like your yeah. Oh, because you added a curve. So by accident. You right click on the yeah. No, right click on there. You want to make it down here. Oh, make it linear. Let me go back to the where'd you go? So my friends, beautiful thing about what we did was we added our first piece of interaction, right? We made a cube move around, and this is our first blueprint with a bunch of nodes. This gives you a sense of what you can do. You can manipulate an object, and all we've done was we've changed its rotation and its location, but you can change its scale, you can change its color, you can do a bunch of stuff like this in real time by using a timeline. It's a great way of doing things, and if you like motion graphs, if you're a math person, this is a great way of showing motion graphs to your class. Like, what do they do? It's done over a time frame, and what it's actually doing is it's using linear interpolation, right? It's automatic inside of the graph, where it basically takes time 0 and time 5 and goes, I'm going to use an even number of divisions between those seconds, because it's a linear curve. If you want to, if I go back to my timeline, I can make this, instead of a linear curve, I can make this a kind of a smoother curve. Let's use it on the bounce timeline. So if I go back to my event graph and go to my cube bounce, instead of it being like this, I can make it curved. And the way to do this, if you actually right-click on a key, you can click auto. And then if I do this for every key, right, then you can change the curve so it's a parabola as opposed to a linear curve. Now what this does is it creates almost like a smooth in and smooth out motion, right? So you can choose the way things move. So it'll accelerate, because it's got a curve now, it'll accelerate and then it'll slow down and it'll come back. So it'll kind of like move up and then go down, and move up, then go down, almost like a little bit smoother than it is right now. Let's try this out and see how that looks different, right? And you can see that it's exactly what's happening. There we go, a little bit smoother. Okay, so that is the first part of our graph. I want to talk about the blueprint again, just to revisit this. It has 5 core parts: the viewport, the components, the event graph. We haven't talked about these two. There's variables and functions. Okay, variables and functions. So variables hold data. That's what they are. They're data members, if you will. I can hold any data I want, but you have to tell your blueprint what type of data. Float types are, and there's different types. Float types are real numbers. So with points, like for example 1.5, that's a float. Whereas an integer is a whole number. So 1, 2, 3, 4, 5, and so on. Discrete numbers. Okay, that's what they are. There's also Boolean types, which are true, false. Right? I can have a Boolean type, a true, false. Those are the 3 most common types, believe it or not. Booleans, floats, and integers. Right? There's also strings that hold text. Typically, that's what they are. Those are another type. And there's other types as well. Like, for example, I can have other types of data that I want to store as well. Okay, so those are variables. Functions are little pieces of reusable code. So right now, as you see, if I go back to my graph, right, my event graph, let's just get rid of these timelines for a second here. This is all nice. These are all nice, but this is all in the event begin play. It'd be really beautiful if I can make all these functions so they don't pollute my event graph. My event graph will have a lot of stuff in it afterwards. What if I had more in my event graph? More and more and more stuff. It'll be like wires everywhere. We don't want this wires everywhere thing. It's really messy. So what we can do is we can collapse stuff down into a function. Okay? I'll come back to you. I'm going to fix you in a second during our break. Okay? So the way to do this, let's try this out. I want to select 2 nodes using my select tool, and I want to right click, and notice if I go down, there's an option to collapse to function. Let's try this. If I collapse to function, it's going to fail. And I'm going to tell you why. Okay? Most nodes can collapse to functions, but there's certain specific nodes, like our timeline, which cannot be collapsed. Okay? And the reason why they cannot be collapsed, I'm talking about it here so you understand, is they're special nodes that are on a clock. Anything that's on a clock has to be inside of our blueprint, our main event graph, right? But if I had a bunch of other nodes, things that I want to connect, like let's say these 2 nodes here, if I want to make this part of a function, for example, if I want to say something like set location, set cube location, let's make these two nodes right here, let's make them into a little function. It's weird, but let's try it, right? So I'm going to highlight these 2 nodes plus their little, reroute nodes, and I want to right click and I want to collapse to function. Now when I do that, it does want something that looks like this. I can name this function something like, set cube location. Set cube location. All I've done is I've just selected those nodes and I've collapsed it down to a function. A function, because it's a reusable set of nodes, right, has its own event graph. If I double click on this function now, you can see that everything that we had before is still there. It just looks like this. By the way, if you're confused, I understand. This is coding, right? So we're going to undo this, but I wanted to show you what functions are. Functions are a set of nodes we can reuse over and over again, okay? So let's just do that. If I undo, by the way, blueprints undo a bunch of things, a bunch of steps. It'll undo all the way to here, all right? So if things aren't working or if you don't like it, you can always undo. Control Z will undo you all the way up, okay, which is pretty cool. So functions are reusable nodes. We want to use them over and over again for some reason, okay? But there's certain things we can't collapse down, like these gold nodes, and there's other nodes you're going to see with a little clock on the corner. You can't reduce those down to a function. I can make a macro, but that's not the same thing. All right, so this is very good. We've done this stuff. We talked about different, the anatomy of a graph. The other thing that I want to talk about is we've only added in, and this is very important, we've only added in an actor. There are three most common types of blueprints we can create: an actor, a pawn, or a character. Actor is the base for all other things you want to put in the scene, okay? That's like your basic node. An actor, a cube, a wall, something that doesn't have any interaction. You want to make something that's going to build up your level. That's your actor, okay? A pawn is an actor that is something that I can possess. I can make an enemy AI out of a pawn. I can move it around automatically with code, okay? And a character is what your character Quinn uses. It's kind of based on a pawn. So we can say the following. We can say a character is a pawn, and a pawn is a actor. Okay? What this is, and for those people who know a little bit about programming, this is inheritance. So the character inherits all of the functionality of the pawn. The pawn inherits all the functionality of the actor. So what that means is, as I move down the line, character is a more computationally expensive object I'm putting into the game because it has a lot more functionality baked in. We only want to use characters when we need to, right? Because they're very expensive. That means they have a lot of stuff built into them. When I talk to my students a lot, I talk about, what's fatter, your parents or your children, right? Who's fatter, right? In real life, the parents are fatter. Okay, let's be honest. We eat a lot more, right? We're more sedentary in our lifestyle. We don't play outside in the yard anymore, all right? Neither do children anymore. But I'm saying we're just generally just fatter, than our children, right? Children are pretty lean until they get older, right? Not so in computer studies. In computer science, the children are fatter than their parents because they inherit everything, all the features. When I say fat, I mean computationally expensive and memory fat. They're full of stuff that they have inside of them. I want you to think about children, child objects, like for example, the character is a child of the pawn is the child of the actor. Child objects inherit all the functionality above them, right? That means they must be fatter in terms of memory footprint compared to their parents. That's why, because of game dev, anything that we want multiples of, thousands and thousands of things in the screen, for example, a particle effect like smoke, we don't want them to be characters. That would be terrible performance, right? We want them to be actors or even something even lower than an actor, which you can have, okay? But these are the basic blueprints or the basic building blocks of things. We already have a character. Let's take a look at our character for a second. Let's go back to Unreal Engine. And I want to look at my character blueprint. The way to look at this is if we open up the third person folder, inside the third person folder, there's also a blueprints folder that was provided for us, right? I want to open up BP underscore third person character. This is a blueprint that's been provided to us for the template. If I double click onto it, you're going to see that it's a much more complex blueprint. All right, you can see that there's other functionality that's baked into it, right? But take a look at the components on the left. The components will show you that there are a ton of things here on the left-hand side that are included. We have a mesh, which is a skeletal mesh. We have an arrow component, we have a camera boom, we have a bunch of more things built in, right? So you can clearly see just by looking at this high level that this is more computationally expensive and fat than anything we just created. Our actor is super low nothing. It just has a little cube mesh, that's all it is, right? With very simple behavior. This is much more complex behavior. Make sense? With that note, I think it's time for lunch. Let's take, we'll take an hour for lunch or whatever time you need. When we come back, we'll actually add some interaction. So we'll actually do something where you can move your character around the level and press a key and it'll do something, okay? So let's take a pause. Any questions before we go for lunch? Yeah, yes?
How do you mentioned it getting the cube to rotate from the center of the point?
You need to bring it in from Blender or have another cube. You can make your own cube in Unreal Engine. It's the pivot point. The pivot point cannot be modified unless you go in, take it into modeling mode, and then, but you're never going to get it. It's not going to look right, right? Because it's Unreal Engine. Anyone? Who else? Yes.
That cube that we created before, you
Yeah.
had one that just fell. I created a new cube above something like the ramp. When I open it up now and play, it doesn't
Fall.
have those physics.
Yeah, because right. So what happens is if you look at your cube, and if you look at the if you actually click on BP_cube itself, and if you scroll down enough, actually if you look at the cube mesh itself, if you scroll down enough, you're going to see that there's physics where it says simulate physics. It's unchecked. If you check this on, then it's gonna fall. Right, but you don't want to do it here in our cube mesh. Our BP cube, that'd be weird because it's simulating physics, but you're making it move all the way around, right?
The one that I made when we were playing around.
Yeah.
So I would have to open up the static.
You can't do it there because you've added in, those things you've added, those camphor cubes are actually blueprints. So you have to make another blueprint, call it, I don't know, and then, yes, and then you can do it that way. Then you can make your own. So let's take a break, let's take some lunch, have some food, and then again, absorb some of the crazy stuff we've done. And then what I'll do is I'll leave this up so anyone who couldn't get it done can kind of bake it in. We're going to use something very similar coming forward because we're going to make two things: a door that opens up and closes up. We're going to use a timeline for that, and we're also going to make a key system, so you can't open the door without a key. Now that is going to be our challenge for today. If we can get to that, it's going to require a lot more programming, and we're going to get to it at the end. So let's take a break. Let's break for lunch. We'll come back at 1 o'clock.